What is up, guys? In this video I'm going to start by teaching you in a very pragmatic way the basics of HTMX, creating components with Templ, and how to integrate everything with Golang. That way you also get a feeling of what we're going to be building, and then after that we're going to code this whole project from scratch together. Take note that this project is simple by design because the goal of this video is to teach you how to integrate these technologies together and give you a heads up on HTMX and these technologies. So I've kept the functionality really simple, just to a simple CRUD system. And what we're going to be building is this list of, for example, a car show, where you can add cars, you can list them, search for them, and we're going to even implement an active search. So for example, as I type here, the results are going to be changing in real time. The whole application is not refreshing. This is just HTML, no JavaScript. And with that, you can see that we can replace all of the JavaScript functionality with HTMX. While this is an introduction, sometime in the near future, I'll be making a complete production ready full stack application in HTMX and Golang. So stay tuned for that one. And if you're not familiar with HTMX, it adds a bunch of new functionality to HTML and making it capable of building complex user interfaces with just the power of hypermedia. Let me just show you here, for example, on the docs. For example, if when you click a link, you can expect the page to go to this link, but here on HTMX, and when you click the link, the page is going to refresh and you're not going to have that feeling of a web application. And HTMX gives us the ability to make requests from any element to the server. For example, take this example, we have this button where when we click, it's going to make a post request to these /clicked endpoints, and the trigger here is click, but this is the default behavior for the button. So, and it's targeting this div for this ID, and it's going to swap its outer HTML. We're going to see that in an example in a bit, and I think it's going to click for you if you didn't got this example. And then the trick is that on the server we are going to be responding with HTML and then replacing the content on the UI and not the whole page. For example, I got a list of HTMX and this list got swapped just on this element here and not the whole page, right? And the same is going to happen when we add. Instead of returning the whole list, we are going to just return a new car tile and added it to the start of the list. Now, the UI that we're building is going to be served from the server, as I have explained you. So I think this tool, Templ, is a really good combination with HTMX because we can just create elements in Go, and how crazy is that? And it's really easy to understand as well. So this is an example of a component, and this is how we're going to be building our components. So let me just explain you how the listing of the cars work here. So how are we displaying this and how the project searcher handles that. And then we're going to check how this car handling works and how we can implement that together before we start the project, right? So here I have on the main Go, basically I have this main function, it's initializing the routes, the database and all of that stuff. And if you check this handle lists car, this is a get request. The first thing it does is it gets the cars from the database, and then it goes to the views, which is going to be in a Templ file, and we just pass in the cars. So if you go inside this view, and then of course we render it at the end, and inside these views, you are redirected to this auto-generated file. So we are not supposed to edit this file here. It's this one, the cars.templ. This is where the templating is done. So you might see that have Templ instead of a function. This is syntax from Templ. And if you're wondering how to get this syntaxing highlights in VS Code, I have listed here on the README how you can set up the project just like the one I have. I'm gonna leave the link below in the description. Basically, follow this link here and you can get started there. So the listing, basically, this is just simple HTML. But here below, I have the components.carList, and this is receiving the cars that we just passed in. If you go inside the cars list, it's just a list, ordered lists that loops over the cars. So this is the power of Templ. So we can just write a Golang loop here in just HTML, and it's gonna translate into a list of these car tiles. And these car tiles is another component that it just has static information about the car tile. So here is a delete button, which has some functionality, but then here are just the display image and the text, the name of the car and all of that good stuff. So again, the flow is very simple. We just did a request to some storage and we are redirecting with HTML instead of being JSON, how in a RESTful API would be, for example, right? This is the only change that we are making. So let's start by implementing this adding of a car feature. And what's happening is that if you click on the add car button, a new UI is going to show up on the screen. And if I just click cancel, it goes back to this initial state, so we can just move out. But after we click here on this second add, the car should be added to the database and then shown here on the UI on the first tile or at the end of the list, for example. So here on the HTML, I just have here a form with these inputs, and here you can see this logic. So if the is adding car state is true, we show this form. Otherwise, we just show the cancel or add car, right? But these are just inputs, texts that are just holding state. Whenever you click add, this button should trigger an event on the form that sends to the posts car. So this post handle add car. We should call this endpoint, which creates a data structure with the car, so the brand, the name, and the model. Then we create the car on the database, and at the end, we just return a car tile, which, if you remember, it's this small implementation of the car, so that static tile there, and not the whole page. So that is the goal. So how do we get started? Let's go back to the cars.temple, which is the page, and here on the form, let's go back to the documentation, and if you remember this button, it does a request. We can do this. So for example, let's just replace this, and instead of being clicked, it's cars. So if we just click this button right now, let's try to make here Honda Civic type R, for example, from 2020. And let me just add some random image, and if I click on add, I can see that the form just disappeared and this car tile just swapped it. So something is working, but something is also not working. So if you take a look at the logs on the network, the request was successful. So we send in the request with every parameters from the form, but the response, and as it should, it returned just this car tile, right? It's correct. It just returned this car tile, but here on the form, it is replacing the whole form. What we want to do is target this list here and adds the new element to this list. And if you remember that, we can do that with the target and the swap. So let's go ahead and choose in the target. And the target is going to be the car list ID. So where does this come from? So I have here the components of the car underscore lists. And here I have the ID car list. And if you take a look at the browser here, this is the whole list that we want to add a new item. So this list item, it's that car tile. So let's target that div. And then what we want to do is swap it. And what's the strategy for swapping it? Here on the documentation, we can just search for the swap. And there is multiple properties we can do that. So the one that you want is actually this one, the after began. So prepends the contents before the first child, so at the start of that list. And now let's try again the adding. So let's go ahead and add the car now. And we can see that the car was added at the start of the list, and the return is the same, it's still a tile. So you can see how this works and how intuitive it is. And if you go back to the list now, here we have the car added. Alright guys, so with that out of the way, let's get started by coding this project. I'm gonna start with this starter code here, and I'm gonna explain to you why and what it does and what I have here. Basically, I want to focus on the HTMX Golang and Templ. So I have this just simple structure that I usually use on my projects. If you want to learn more about how to build an API in Golang, I have a video on the description that I have made on the channel. You can follow it, and the structure is going to be pretty similar, which is how I do all of my projects. And basically here we have the store interface and the implementation for it. This is how we are communicating with the database. So I'm not going to go over it. It's very simple, just a crude application. And this is the interface that we are communicating with for the service. Then here on the main file, we just initialize the database. You can also get all of this code in the description below as well if you want to follow along there. And then here we just initialize the store service, the storage, and the router. Here I'm using Golang for that. You can easily swap this with standard library as well. It's very easy. And then I'm just having here a handle func for the handle home, which renders this view. And if you go here to the views, I just start with this home.temple, which is just this car show example. Everything here is wrapped by this page, and the page is where we have the basic HTML. So here we have the heading, the title of the page, and this is where we are going to add HTMX and Tailwind as well. So the first thing that we need to do to get HTMX is, let's go back to the documentation, and now let's go to the introduction, and here somewhere should be an installation. So we are installing via the CDN, so we can just go ahead and copy this line, which is going to install the latest version. Good. Then we just need Tailwind, and the way that we are installing Tailwind is that here I have on my make file a command that it requires the Tailwind CLI. If you want to know how to install the Tailwind CLI, go here to the README, and you can just click and follow this installation for your environment. But after that, you can just do make Tailwind, and what it's going to do is it's going to go to the views. So here, CSS and styles. So this basically imports Tailwind, and then it's going to convert all of that Tailwind to the public/styles. So if you just run this and cancel this execution, you can see that when you go to public styles, here you have the whole Tailwind generated for your project. So that is how we're going to install Tailwind. But here on the HTML, we need to reference that file here that to load these styles, right? And to do that, we just have a very simple link reference to that file, right? Nothing special. So this is it. And here we have the spread operator as well. So we can just wrap pages like this, like so. We can just wrap them. And if we want to have a navigation bar, we can just say true, otherwise just say false. And we are controlling state on this wrapper page. Now you might be wondering, why is this error here? So we have the views and the home here, the home temple. They are created. Why is this component not being detected? And the thing is that when you saw that those Go generated files were just gibberish, those were actually the components that Templ generates. So we have these Templ files. These are declarative structure, but we need to generate them in order to be compatible, right? So let's go ahead and do a make Templ. And this is a watch process, so we can just cancel it for now. And what it did is that it generated a couple of files here. So it generated this home.temple.go. This is the Go code for that template. And here the error just disappeared after that. So whenever you are generating a temple, make sure to run these commands. What I recommend you is to always keep 3 processes running. So for example, I usually have the make Templ, and then I have on another window the make Tailwind. So the Tailwind and the Templ files are always being generated as I type. So when I save the file, it generates, and if I go to the browser, the UI changes automatically without having me to reload the page. And then we just start on listening the API on this port 8080. So let's just go over this init function, and basically what it does, it starts the database connection, and for that we need to I'm going to show you how you can do that as well. So here I have a Docker container running MySQL, and basically here on my database what we can do, so I've just created a new database called cars. You can do the same. If you go here to the config db.name, you can just change the name of your database, for example. mine is called cars, and what we do now is that here I have a tool called migrate. Here I have some migrations, so you can start your own database. So this is the up and this is the down. Again, it populates with some data that we saw on the demo. To run this, just go ahead and do a make migrate up, and it's going to generate the tables and populate everything. So if you go here, I have here the cars table and the data generated. This is just an example so you can get up and running fast. And finally, to run the Go server, I'm running this tool called error. You can see again on the README file, it's everything there. Basically, this is a hot reloading for Go, so whenever I change the file, the whole server is going to be recompiled very fast. It's very powerful as well. So I just type error, the server is running, so connected to the database, everything is working. So we can just go ahead and do make tailwind as I've shown you. And finally, the make Templ, and it's gonna open up the browser. So this is what we start whenever you click the cards on this link. You can see that nothing happens, we get a 404, and this is what we're going to be implementing in this video. So let's get started by creating ourselves this new endpoint, because if you take a look at the page.templ, more specifically the home.templ, you see that this link here, it's an href, so nothing special. It should redirect to a new page. Even here on the page.templ, here we have the navbar, and whenever you click on the button, we should be redirected to an endpoint, so it's going to make a request to the server. So let's go ahead and make a router.handlefunc, and the route is just cars, and here you should have something, but the method is going to be a get, sorry. And the handler is going to be, for example, handle cars list. And let's go again here at the, let me just close this file, at the handlers. I'm going to create a new handler domain, which is going to be the cars.go. And let's create a method for the handler. So this is going to be a method inside of the handler. The handler is just this struct that we just initialize it in the main file. It has a service, so this is a dependency of the storage. Why is this made? So we can easily test this whole thing without depending on storage implementation. So I can just inject this. Remind you, this is the storage struct, which implements the store interface. So we can easily mock this as well. Even just passing here the store as well, it would work. So let's go ahead and do the handle cars list. It's going to receive an HTTP response writer and a request. After that, the first step is to get the cars from the database. So let's go and consume this storage. I know that this is going to be on store, get cars, and we don't need to pass anything. Let's just easily handle the error for now. We're not going to take a look at it. Let's just log it, error, and then let me just return. We can handle this better at a later stage, but for now let's focus on some value for the application. And here what we want to render is a page that we do not have, which is going to be called, for example, cars or cars list. I'm going to keep this cars. Just going to keep this comment for now. Let me save the file, and let's go ahead and add the views. So this is going to be a page, a view. I'm going to call this cars.templ. And inside the Templ file, we are going to define this inside of the package views. And to make a component in Templ, we just say Templ instead of being func. It's going to be Templ, very similar, and you call this cars. What is going to receive? It's going to receive the type of these cars, which is going to be a slice of types.car. If you take a look at this, it's just this structure, direct mapping from the database structure. And here we just return some HTML, something. Let me just import the car like this, because I'm lazy. And then let's just have a simple div, just saying cars list view. Okay, so here the compiler should do the work. If you take a look here, the cars.templ has a cars.go here. And if you're wondering about this txt. This is just for development purposes. This is what Templ does behind the scenes. I don't know much about it, but you can ignore it. Here we have the views package, and now we have access to the cars. We can pass in our cars. We can render it to the reader context, like so, and pass in the writer as the second parameter. We can save this, and here I think everything is done. Let's save this as well. Let's go back to the project. Let's try the flow again. So if you click on cars, we should be redirected to this view here, and it is working. So you see that something is missing, the nav bar is missing, so this experience is not the best. Let's go back to the Templ file of the cars, this one, and let's wrap, as you guys saw, a component for the page. So it's a page, say that we want a nav bar, and we just wrap what we did here. Let's go back to it. We just refresh. We can see that the list is now seamless here, right? So here I have just quickly styled a bit the page so it looks a little bit more decent, centered that title, and let's go ahead and start rendering the cars. So I'm going to show you how you can create a component. So let's just make a smaller component instead of being a page. It's really the same idea, just how we divided it, that's what matters. So I'm going to call this cars list.templ. So here let's just create the cars list. Right, so whenever we save, the file should be generated here as well. Awesome. What we want with the cars list is just rendering a simple ordered list, and then we just loop over the cars. So let's receive here again the cars slice types.car, and then here we're gonna loop over this structure and render something here. So let's create again another component, which is gonna be the car tile.templ. Car tile, and this one is going to receive just the types.car itself. And here, if you go back, you can just access the component like this. So we can access, because it's in the same package, we can just do this car, and we pass in the car inside this like so. It's actually called car tile. So this is going to be the list. Now let's add some styles to the car tile, otherwise we're not rendering anything. And here I have quickly styled this, so I just added some classes from Tailwind. Here I have a span with the car brand, the model. This is how we access the properties. We can just have all of these properties here very easily, and then here the image as well. So the last thing that we need to do is then again render the list that we just created, right? So let's go to components.car lists and render in the cars that we just received, which I forgot to add here the name, cars. So if you just save and let's go back to the application, we can see in real time that it just got the whole list of the cars right here. So let's go back to the home, click here, you can see that we have the whole list. So at the start of the video, I showed you how you could add the car and all of that jazz, but let's go ahead and do something different, and let's start by creating the deletion of the car on the list. So let's have here a button below, and whenever we click it, we're going to delete the clicked car tile. So how can we do that? Again, first thing is that we need an endpoint. So let me just copy this. It's going to be a delete, and let's call this handle delete car. Let's go back inside of this and just create a new function, because I'm just going to copy these parameters here because I'm lazy. And then the first thing that we need to do again is call the store. So let's go store, delete car. We need to delete the car in the database, but somehow we need to get the hold of an ID. How can we do that? Let's think about it. So let me just save this file. Let's go back here to the cars lists inside of the cars.tile. So our goal is to have here a button. So let's just create that button. So whenever we click this button, we want to delete this car. How can we identify this car? We can use the car ID to identify it. And how can we pass in the ID? So if we go ahead and make here an hx.delete, so remember, here is the verb. It could be a post, a put, something. It's going to be a delete because we decide this. to be a delete here. So the endpoint is going to be /cars /id, right? Doing vars and then doing max.vars. And then we can access the ID by doing vars/id and accessing directly this property. So I could check that the ID is valid. All of that, I'm just going to send this to delete car, get in the error and handle it. And then here, how we do this. So instead of rendering something, we are just going to write a header, and I'm going to do is going to be a status dot http dot status. Okay, we're going to go back to this in a bit, so keep that in mind. And here we pass in the requests. So let's go back here to that now. So we are accessing this delete, but how do we delete this exact element? So let me show you what is happening here. So if I click on delete now, we get an error of 405, and if we check the logs, we see that again something failed here, and it makes sense because the URL does not have the ID, right? So whenever we clicked this delete, we need to somehow pass in the URL to the ID to this URL, right? How we do this is that we can just concatenate the string, so fmt.printf, just like you do in Go, and pass in the format. So it's going to be /cars /in a decimal, and then the value is going to be the car.id. So if we just save and go back and click on the delete, we can see that we got a 200, something happened, nothing responded, but we see that this button just disappeared. And as you know, this is the default behavior. We are deleting the button, it's being swapped by nothing because we returned nothing. And there is a very interesting thing that we should take into consideration, which is when we delete, it's going to target the element itself. So we want to target something else. So for example, here it is targeting the body. So let's go ahead and target in what we want to target. It's this whole tile. And to identify this tile, we could add, for example, here an ID. Again, we need to add in a generated ID. So sprintf is going to be, for example, car, and then we just pass in car.id. Then the target is going to be this here that we just wrote, the ID, and we are targeting by the ID. So this part here is important. So if it would be a class, it would be like this. So this is basic targeting HTML syntax with the query element. So it's the same syntax. If we just refresh this page here and we hit delete, we see that this style disappeared. So we are almost there, but we are not deleting. So this is swapping the data and not deleting. And if you take a look at the documentation, we need to go here at the HTMX swap strategy, and there is a strategy to delete. So it deletes the target independently of the response. So let's go ahead and add the final piece, which is the swapping. Let's save. So whenever you have problems with the swapping, everything works, but the element stays there, or it's not added correctly, it's usually because of the target or the swap. So check that. So let's go ahead and try to delete this master tree. And if we delete it, we see that it just disappeared. And this is again the response. If we refresh this, the car is gone from the database and from the list. So that is how you can implement deletion from these lists. And there is a very important detail that I want to mention you, and no one told me. And it's something that it could leave you some hours of debugging hell. So to remove the element from a successful delete, return a 200 and not a 204, because it will not take the swap in place. So here on the endpoints, when we return the right header OK, if we just return a 204, it will not take the swap into consideration. So don't forget that when implementing deletion, always read through the documentation. So to finish everything off, I just want to show you how you can implement the searching, because I think it's a more complex feature. So let's go ahead and go back to the cars lists temple. Here I have just added these very simple inputs, and we're gonna build the active searching. So what that means is that as we type something here, the list is going to be changing and showing results debounced. So if I just type a lot of things and I stop, it's gonna do a request. If I delete, it's going to make another request, and it's not going to make a request on every key strike because that is very slow. It would make X amount of requests, which at the end of the day, we just want the last, the key, right? So the first thing is that we need to make a request. So it's going to be a get. It doesn't make sense to do anything else. And we are going to do a /search. We're going to search for the name. Then we want to target the cars list. So this is the cars list. We don't have this ID yet. So let's go to the car list.templ and add in this ID to the list. Go back. So whatever the search endpoint returns, we're going to replace the whole list with the results. And then a trick here is that the trigger is not going to be the click or anything else. It's going to be a key up or key changed with a delay of 500 milliseconds. So how easy is this, right? This is just implemented what I have said, which is that key request. So whenever this meets, it's going to make these requests with this delay of 500. So whenever I do this, it's going to make a request, as you see here. If I just type a lot of stuff, it's going to make another request. If I delete this, it is removed. And if we deleted this delay here, then as I would type, X amount of requests would be made. And you can see how bad this would be for the server. We're just bombarding the whole server with useless requests. So let's go back to the main. Following the same strategy, let's copy this and do a cars /search. It's going to be a get. I'm going to move this here. And then it's going to be handle car search. Again, very easy. Here I'm reading the value from the form. So this is going to be the search inputs. I have named it search here. So this is the one. Then I go to the database and I find cars by name or brand or make. And then I just have the cars from that search. Then we just render the components .car list that we already have. We pass in the cars, the new ones, the filtered, and we just say the context. And then the writer as well. So this is it basically for the search. Let me just handle car search, save this, there was a typo, and let's go ahead and test it, right? So let's go ahead and search, for example, for Mazdas, and we see that we got all the Mazdas. And if we delete this, let me just open here the DevTools for the network. If I search for the Toyotas, we just get the Toyotas, and if we delete this, we get all the cars. And because I have just deleted a bunch of them, there's just one Toyota back. If I search for the MX-5 Miata, I get the MX-5 Miatas here as well. And there is just a problem here. Let's take a look at the HTML. So you can see that there is a double list here. And again, this is a very common HTML problem, HTMX problem. What is happening is that we don't have the exact swapping strategy that we want. So let's go back to the inputs and add an HX swap. And the strategy that we want is the outer HTML. So currently it's the inner HTML, if I'm not mistaken. And we want to return and swap the whole outer HTML of the car list. So let's go back and refresh this. Search for the MX-5. And you can see how fast this is, the search is. And you can see as well the list is fixed. So again, if you search for Toyotas, the list remains the same and it doesn't add other layers as we saw previously. And it's also interesting to see how the HTML is changing on real time and not the whole page. We're not making any page requests. So this is it, guys. This is the power of this stack. And I'm going to build a complete project in the future with this whole stack, production grades. So stay tuned for that one. And with that, I think I have shown you how you can build this project even further and add those edge cases that I've shown you, which are very valuable. It would be very valuable to me, at least when learning. So let me know if you guys liked the video, give a thumbs up and consider subscribing. and check the channel because there is a lot more content like this there. So see you on the next one.